Hello everyone, welcome to the Mechanism Sessional Lab group project. Myself Ritik Bishwas, a third year undergraduate student in the Department of Mechanical Engineering at IIT Kharagpur, enrolled in its BTech program. Today we have an exciting project on the table that involves the tackling a real world problem in the area of the railway accessibilities. Our mission is to design and simulate a railway ladder system to find out the simulation that enhance the accessibility, to train a course for the platform or the varying height. The challenge is not just to create the functional ladder, but to infuse the innovation in the design. We are tackling our automation and locking mechanism and mass mode. This is the program that is a mechanism sessional in the year of 2023 and 2024. Now let us introduce our brilliant mindset behind this project. Our team comprises Coach Ritik Bishwas, myself, Shantan Sharkar, one of my teammates, and my another teammate is Shomik Naik. Together we are driving into the interfaces of the synthesizing and simulation a cutting-edge railway ladder system. Me, Shantan and Shomik are bring a diverse set of skills from mechanical engineering to innovations. This team is a gear up to the revolution part, the way and the broad trends. Now before we get into the nitty and gritty, let's take a look example of the roadmap. Now this project roadmap. We are kicking up the things today, that's the introduction part. Understanding the problem statement. The second part is the synthesis part, displacement and the velocity analysis. And the third part is the simulation part, SolidWorks CAD design and the MATLAB simulation. Area of innovation, improving the mechanism for the effective uses. We are kicking things up the today and the introduction, giving the glimpse of the problems we are tackling and the goals what we have said. Next we will deal the synthesis phase. We are conceptualize the area and put over on the pen and paper. Then we'll jump into the simulation phase. We things to get exciting as we are bringing to the design life on the virtual stress. And of course, and the next part, the introduction, is a problem statement. A railway ladder system is being contemplated for the ease accessibility of the train course from the platform of the different levels, as shown in the synthesize and make a simulation for the ladder as the new ideas might have. And of course, we have a dedicated segment for the innovation area, and this is where the magic, real magic, happens. We explored the novel concepts and the idea were incorporated into the railway ladder system, such as the automating opening and retreating using the motor and the key blocking mechanism to ease of the loaded. So our journey is just begin. We are thrilled to have you along with the ride. Now I hand over my presentation to Shomik.
Hello, I am Soumik Naik, 21ME10111, and I will explain the synthesis part. So, first of all, this one is a diagram of the ladder. So, this two represents the ground linkage. This one is the second link, this one is the third link, and this one is the fourth link. So, now I will move on to the MATLAB code which we made. So, this one is basically the MATLAB code where L1, L2, L3 and L4 we have already specified. We are only going to change the theta 2. We are calculating the values of theta 3 and theta 4 with the help of the Newton's raption method through iterations. First of all, I'll place theta 2 as 40 degrees. This is when the train is at a station and the ladder is open. So we are getting the values of theta 3 and theta 4. So theta 3 minus theta 4 is basically around 80 degrees. So basically this 80 degrees is the angle between the two arms of the ladder. So basically the ladder is open and the train is standing at the station. The velocity analysis omega 2 I have provided at 10 radian per second. So I'm getting the values of omega 3 and omega 4, and also the magnitude of the velocities. For acceleration, I have put A2 as 4, and we are also getting the values of A3 and A4, and the acceleration of the joint C. Now I'll change the value of theta 2 as 14 and run the code. Now we can see that theta 3 and theta 4 has changed, and the difference between theta 3 and theta 4 is very less, around 14 degrees. So basically we can say that the ladder has been closed and the train is not standing in a station, train is running. For the velocity analysis we can also see that omega 2 is omega 2 is 10, and so we are getting omega 3 and omega 4. And for acceleration analysis, we can see that alpha 2 have kept as 4, and we are getting the values of alpha 3 and alpha 4, and also the magnitude of the acceleration of the joint C. Now I'll move, this is basically the CAD model which we had designed, and I'll move on to Cyanten.
Thank you, Shomik. Hello, I am Shantan, 21ME10073, and I am going to talk about the CAD model simulation and the constraints that we have considered while making this foldable staircase of the train model. Now, I am taking you back to the CAD model that I have made in SolidWorks. So, this is the total model containing the train side wall, and here is our staircase mechanism, and here is a platform. So, if you see from the side view, so I'm changing the transparency and showing you from the side view. Here you can see the mechanism, the exact mechanism, where we have taken the link length based on our target geometry parameters, including the angle of the link of the lens. And here is a four-arm linkage, this, and that. The ground ones, these and these are fixed. So we have taken into consideration constraints like the actuator range, so that this actuator doesn't collide with the train like boundaries, whatever walls it is there inside the inside the like in this space, it should not collide with any other walls. Now, if we talk about the lowest stair, you have to take care that the middle stair should hit the platform, but the lowest stair should not hit the platform while it is folding back to its original position. This should be taken care because if it collides with the stair, then it will be a fault on the like design side, and it will not be able to close to the fullest extent, and there will be pressure on the motor. So they should be taken into care. Now the whole stair after full closure should be inside the train chassis. So you can see that this folded staircase is inside the chassis range of the train. So this is also one of the constraints that we have taken. Now let us go back to the PPT. So this video I am playing to show you the actual mechanism of the foldable staircase from its extreme positions. Now, I want to throw some light on the area of innovation that we can think about using this model. So first of all is the end positions. So the actuator will contain the end positions fixed, and those constraints should contain a dimaterial. That dimaterial should be made of some good hardness, and it should contain a piezo sensor because it measures the pressure change that is happening while boarding of the passengers. So by looking at those graphs from the data acquisition system, we will get the pressure gradient, which will let us know whether the passengers are boarding on the train or not, and this will be a helpful data while deciding the motion of the staircase. Next, for the locking mechanism, we can use this shaft key or radial gear. So why we are using locking? Because at the extreme positions, while the passengers are boarding, that the loads of the passengers will exert torque on the motor, and this may damage the motor in the course of time, because there will be a rapid flow of passengers, and there will be a fatigue load acting on the staircase. So we are using a lock and key mechanism here. How this the innermost shaft is the shaft of the staircase. The middle one is the motor torque producing object, and the outer is the lock. So what happens is when the folding of the staircase is done, the motor is detached from the lock is first attached to the shaft, and the motor is detached. So the lock holds the staircase shaft until and unless until and unless all the passengers are boarded and the signal comes to fold it back. So once the signal comes, then the lock will detach after the metal is again attached to the staircase. So it will also let it fold to this to its original position. Next, we can use proximity sensors to detect the platform elevation. So in the first point, I mentioned to give some restrictions on the extreme positions of the staircase. Here, we can use proximity sensors to perform elevation so that the middle stair can rest on the platform, and the torque can be little balanced by the normal force by the platform. We can also use linear actuation to adjust operator shaft. So this is another area of innovation that we can think about. And this linear actuator can be again provided some input signal based on the criterion. Now we can also get a mechanism for an inclined plane for handicapped passengers who want to move on wheelchair. So this is our current model, and we are getting a configuration in which this whole staircase is acting like a plane, so the passengers can be easily boarded. So obviously this won't work in that manner. This the hinge of the operator should have to be linearly actuated to some level, and this will lie on the platform like an inclined plane, and the passenger can be easily boarded. So this is again another innovation that we can think about on this project. Thank you everyone for your patience. I hope you liked our model. If you have any doubt, please mention that in comments. Thank you so much.